Hello everyone. So I am Narendra Kumar Jha, and this is the subject of elements of mechanical engineering, and this is the lecture 3 and unit 1 of the syllabus. So first of all, thermodynamics, the basics of thermodynamics. So thermodynamics means the motion of temperature or heat, or we can call it as a heat transfer. So the heat transfer will take place if there is a temperature gradient, means temperature difference. So due to the temperature gradient, the heat will transfer from hot body to cold body. Okay, so this is the basic definition of thermodynamics. So the applications are steam power plant, nuclear power plant, internal combustion engine, gas turbines, and many more. So every engine in mechanical engineering or in any other branch, so there is always thermodynamics. That means there is always heat transfer, energy transfer, and work transfer, and somewhere there is a work transfer also. Okay, so this is the example. See, solar collector placed on our house, so that will collect energy, and they transfer this, and we are utilizing those solar energy in the form of electrical energy, okay, to light our room, or for other purpose also, for heating purpose, for cooling purpose, etc. Then hot water tank, to store the hot water. Okay, there is a pump, there is a heat exchanger. The function of heat exchanger is to exchange the heat. Okay, so there is a shower. So this is the example, basic example of thermodynamics. So the human body is also example of thermodynamics. We are also transfer heat. Air conditioning systems, aeroplanes are there, car radiators are there, power plants are there, refrigeration systems are there. So these are all comes under thermal engineering. And you can also comment in my comment box the other examples or the application of thermodynamics in our day-to-day life, or any other example you can comment. Okay, so I will wait for your comment. Okay, so the basic concept inside the thermodynamics. Okay, so here we will study the heat, concept of temperature, and then concept of enthalpy, entropy, heat, work, etc., and the governing laws that will utilize those concepts to clearly better explanation of the thermodynamics. So what is going on inside the thermodynamics. Okay, so first of all I will go as per syllabus. Okay, a thermodynamic system, there is a system, there is a surrounding. Okay, so everywhere to solve any problem there is a system and there is a surrounding. So the first question arises in our mind is, what is this thermodynamic system, or what is system? First of all, what is system, and then what is thermodynamic system? So system means anything, means quantity of matter. There are 2 points, the quantity of matter, or second point is region in space. Okay, quantity of matter means there are 3 types of matter available in our universe. Okay, there is a solid, liquid, and gaseous. So these 3 states of matter will be the complete sense of all the material available in our universe. Okay, so we will select either solid material, liquid material or gaseous material for research purpose or study purpose. Okay, so see, again, inside the solid material there are lots many material available. Okay, so solid material, so see, inside the solid material there are aluminium, copper, composite material, etc. So the researcher or scientist, they select one material at a time for the research or study purpose. So this is the quantity of matter, what I want to say. This is the quantity of matter. Now see, for the study purpose, so this is also system. Okay, the second is the region in space, means in our universe there is a huge space available in our universe, but we try to select some particular space to study or for the research purpose. So see, for example, see, there is a college, there is a school. So the school or college, so the particular college is the system under which we are working. Okay, so that is the system, and the remaining thing are surrounding. So now you understood, I think. So there are 2 points, either quantity of matter means select some particular material for the research or study purpose where we want concentration, okay, for the analysis of a problem, okay? Or region in a space means out of huge space we have selected a particular space for study purpose like a school, college, okay. So now see, and the remaining thing are surrounding, or we call it as environment. So first of all, the definition is, the thermodynamic system is defined as a quantity of matter or a region in space upon which attention is concentrated in the analysis of a problem. Okay, the surrounding is the everything external to the system. It's called the surroundings or the environment. Now the second, so the system and surrounding is clear to you now. Now the third thing is system boundary. What do you mean by system boundary? So the boundary is the, boundary separates the system with surroundings. That is called the, that will be the boundary. Now see, this is the boundary which separates surrounding and system. From this system, surrounding is separated with the help of this boundary. Okay. Now this boundary may be fixed one or movable one. So this boundary may move also. Okay. So this is the system for the study purpose. Okay. So this is the piston cylinder arrangement as it is clear from the figure. So now see, there is a open system. Now see, can you say, can you think that a system plus surrounding, what you called? See, now I answer you. The system plus surrounding means universe. Okay, because from the universe only we have selected particular space or quantity of matter. So that is the system, but the remaining are surroundings. So system plus surrounding is universe. Okay. Now come to the second point. Second point is the what are the different types of system available for the study purpose. So the first is the open system, the second is the closed system, and third is the isolated system. Now see, so what is going on in case of open system? So in case of open system, as you can see from the figure, that in case of open system, this is opened. Okay, so there is a mass transfer, because suppose there is a liquid containing, that maybe suppose we take water as a liquid in this beaker. Now we are supplying heat. Okay, so as we are supplying heat to this water, so the water is stored this in the form of internal energy. Okay, now this water starts boiling. Once it starts boiling, the water molecule will evaporate it and go into the space. That means water molecule is going, means there is a mass transfer. As you can see, the direction I have shown, it is open, so the water will go out, and of course there is a energy transfer as it is open, not insulated, so there is an energy transfer. Okay, so this is the first point, that is the open system. Now see the closed system. Now we are keeping one device or one some sealing, something for the sealing purpose. So here it is sealed, means there is a no open system. Now the mass will not transfer. So see, once the water boils, it get condensed. So there is a evaporation and condensation process will takes place. So now again this water molecule drops out and again sits at the top or bottom of the this here in the beaker. Okay, so as you can see from this figure, that in case of closed system there is a energy transfer only. So because of this sealant, the mass transfer is stopped. Okay, in this case both is available, but in the closed system one part is closed. Now see, in case of isolated system, so in case of isolated system there is a complete isolation by using thermocol or other thing. We insulate this system, so now the energy transfer is also stopped. So both is stopped, means neither mass will transfer nor energy get transferred. Okay, like thermoplast is the best example as we are using in our daily life. So the thermoplast is the best example because you can observe easily, least costly also, so you can see, you can check also. Okay, so in case of isolated system there is no energy transfer, there is no mass transfer. Okay, so there are three types of system: open system, closed system and isolated system. So can you comment, can you give the example of open system, closed system and isolated system? Okay, you can give the other example in my comment box. First of all, see the open system, all engineering system are open system only. Okay, they are like air compressor, IC engine, etc. And isolated system example I have already told you. You just go and search closed system example. Okay, now see the same thing is there by the diagram. In case of open system, when there is a mass and energy transfer between the system and the surrounding takes place, then we call it as a open system. Closed system, when matter and energy, when there is only energy transfer, matter is not transferred, so it is called closed system. Isolated system, neither matter nor energy transfer is takes place, so this is called an isolated system. Now come to the second concept, that is the control volume and control surface. So control volume is, this is the control volume. Volume is the space, the empty space. First of all, see the area concept. Area means, suppose this is the room, so the ground part means length into breadth. This is the area. Now if we consider the height also, length, breadth into height, so this is the volume. Okay, so this is the control volume. Control volume is volume neither increase nor decrease, so this is the control volume. And the surface that cover this volume is called the control surface. So now you better understood the concept of control volume and control surface. Now I will explain the interaction medium, that interaction that is going between system and surroundings. Okay, So as you can see that interaction media is the energy transfer and mass transfer. Okay, and again energy transfer means heat and work transfer. So I have already explained you. Suppose there is a in cylinder piston available. So I will show you. See, so we are supplying heat. So this system will store this heat in the form of internal energy. So some part they give as in the form of external work. So this will give thrust. Because of this internal energy, this will give thrust on the piston, and this piston in turn rotate the wheel and the vehicle move forward, and that is our target. No, so see, suppose this system is giving force of 70, no? Means out of 100 kilojoule heat, the 70% is utilized for running the vehicle, that is the external work done, and remaining 30% this system stored this 30% heat as in the form of internal energy, and this internal energy, so there is a energy transfer out of those 30% internal energy. So this vehicle is having 70% efficiency. This vehicle is having 70% efficiency. So can anybody say about 100% efficiency engine is possible or not? Please comment. So see, the Carnot engine, one of the famous scientists named as Sadi Carnot. So they achieved 100% efficiency, but unfortunately the Carnot died in the night, but they achieved. But other scientists tried his level best to find out that how he get the 100% efficiency engine, but they unable, they can't. So they unable to find. Okay, so now we are struggling, we are getting only 70, 80, 90% efficient engine. Okay, so this is the concept. Now this is the interaction media. Now see, this is the example of closed system. As piston cylinder, in the form of piston cylinder arrangement. This is the open system, mass in, mass out, and this is the isolated system, neither energy nor mass transfer. Okay, so in case of closed system, this is the energy transfer and this is the mass transfer. So thank you so much. Please like my channel and subscribe also, so that you can get the update. And like my channel also. Thank you so much. Best of luck.